Okay, so welcome back. We're going to continue reviewing. This is still all Unit 5 stuff. There was a lot of information in Unit 5. So some of the formulas that you're going to need to know, you can, we'll have them up on the board, but you need to make sure you have as many as you can. So calculate the discriminant of the quadratic equation. So the discriminant, okay, remember, is what's underneath, just what's underneath the square root symbol in the quadratic formula. So the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's your whole quadratic formula. The discriminant is just, so discriminant is equal to b squared minus 4ac. Okay, so it asks you to calculate the discriminant and then explain the relationship between that and the types of zeros you're going to have. So if we were to calculate, okay, our a value on this is 3, our b value is negative 12, and our c value is negative 1. So if we plugged into here, we would have negative 12 squared minus 4 times 3 times negative 1. Okay, negative 12 squared, that is 144. Negative 4 times times positive 3 is negative 12. Times another negative 1 is going to give us plus 12. So this is ending up giving us 156 is your discriminant. Not the square root of 156, just 156. Okay? Now, it asks you what's the relationship. Because this is a positive number, okay, therefore, that's what these three little circles mean. So positive, therefore, the quadratic has 2 real zeros. Okay, so that means that this graph, if I were to sketch a very basic graph, looks something like that. Maybe not exact, but something like that. Okay, so it hits it 2 separate times. 1, 2. It has 2 real zeros. All right, let's go over and let's look at the next one. So on the next one, my a value is negative 2, my b value is negative 2, and my c value is negative 10. So if I start to plug in, I'm going to have negative 2 squared minus 4 times negative 2 times negative 10. Okay? Negative 2 squared is 4. Negative 4 times negative 2 is positive 8. Times another negative 10 is going to give us minus 80, which is going to give us negative 76. Okay? So that's your discriminant, just like 156 was your discriminant on this one. So if it asks you what is the discriminant, it's those numbers. Then if it goes on and says, okay, what does that tell you about your graph? Because this is negative, therefore your quadratic has no real zeros. Okay? That's when we're going to get into the complex stuff. That's when you're going to get complex zeros with i's. So it has no real zeros because that's a negative number. So this one looks something like this. All right? So it never hits the x-axis. That's why we don't have any real zeros. The only other type of discriminant you can get is 0. So if your discriminant is 0, then quadratic has 1 real zero. So that's going to be, that doesn't happen quite as often. And that's when you have a graph and your graph comes down and the vertex is the solution. So it only hits it that one time. So you can see what that one looks like. Okay. Now, moving down. So this is stuff actually from my honors algebra class. I just like that it was set up and it kind of hit all the different key features. So that's why I wanted to show you guys. P is the same thing as C prime. So this is just focal length. So, you know, you can write that up there if you need it. So P and C prime equal focal length. So on here it says P value, and then on yours it might say C prime, but it's asking for focal length. So this is where you kind of have to play like a game. Like you're kind of given certain parts of information, you got to figure out those other parts of information. So we're going to start with that our vertex is at 3, 3, and our focus is at 3, 1. Okay, if I have to go down to get to my focus, that means my direction of opening is going to be down. Right off the bat, that's an easy one to fill in. Also, I know that from my vertex to my focus and my vertex to my directrix are the same amount, all right, just opposite directions. So I went down 2 to get to my focus. Let's write that that's our vertex. This is our focus. That means I'm going to go up 2, and this is going to give me my directrix. Remember, your directrix is always going to be a line, so this is going to be the line of y equals 1, 2, 3, 4, 5. Your axis of symmetry, it always cuts through your vertex. It also cuts through your focus. So your axis of symmetry is going to be coming in this direction. And so this is going to be x equals 3. And then in this case, your focus, to figure out your focal length, all right, you're thinking about how did you move? Well, to get from your vertex to your focus, you went down 1, 2 units. That means my focal length is -2 because I went down 2. The negative, I know in terms of length, you don't see negatives very often, but it's telling us direction. So it's there to just kind of aid us with that. Now, your A value. So you have an equation that can go either way. So you have that A is equal to 1 over 4 C prime. Or you can rewrite it as C prime is equal to 1 over 4A. So depending on the information you get and depending on the information you're looking for, you can interchange that A and C prime value, or A and P, you know, however you want to write it either. Okay, so if I'm looking for my A value and I have my C prime, then I know it's going to be A is equal to 1 over 4 times -2, which is going to give me -1/8. That's going to be here. And so then if I want to write my equation, it's always going to be easier to write in vertex form. So I'm going to write my equation, y equals -1/8 x minus h. So my vertex is at 3, so -3 squared plus k, so plus 3. That would be the equation. Then to do domain and range, it's the best way to do that is to sketch it. And so something that we talked about a while ago but haven't talked about for a while, and I don't know that it's necessarily going to be tested directly, but it might, is using your focus to find what are called your locus points. All right, and I know that kind of sounds funny, but so from your vertex to your focus and your vertex to your directrix, those are always going to be one focal length. So in this case, -2 is our focal length, so we went 2 units, 2 units. If you go 2 focal lengths from your focus in each direction, so 1, 2, 3, 4, 1, 2, 3, 4, you get what are called locus points. So locus points are points that are on your quadratic. So now we can come and we can kind of sketch, and we can sketch, and it gives you what that quadratic is going to look like. So your domain is always going to be all real numbers. Your range in this case is going to be from -infinity until you hit 3. And our distance from our focus to our directrix, 1, 2, 3, 4, 4 units. Okay, that's a lot of information. Like I said, I don't know how in depth it's going to go. I highly doubt they're going to ask any domain and range problems. So if you're having trouble with that, I wouldn't worry about that too much. But I do know that they're going to ask about that focus and directrix, so understanding the relationship between the two. Okay, next one. It tells us that our vertex is at 1, -5. So 1 and then -1, 2, 3, 4, 5. This is our vertex. It tells us that it opens up. And then it tells us that our A value is 1/8. All right. So in order to find our focus, directrix, and stuff like that, I need to know what my focal length is. And so that's when I'm going to use one of these formulas. So now I'm looking for focal length. So I'm going to use C prime is equal to 1/4, and then my A value is 1/8. This is going to simplify to 1/1/2, and then anytime that you divide by a fraction is when you have to keep, change, flip. So I'm going to keep, change, and then flip. So I'm going to keep the 1, change to multiplication, and flip 1/2 to 2/1, which is just going to give me 2. So that means that my C prime is equal to 2. Well, now I can go find my focus. Now I can go find my directrix, because now I know that if it opens up, that means I'm going to go up to get to my focus. So I'm going to go up 1, 2, and that's going to give me my focus. I'm going to go down 1, 2, and that's going to give me my directrix. So our focus is the point 1, -3, and our directrix is the point y equals -7. Axis of symmetry, again, is going to cut through your focus. It's going to cut through your vertex. So it's going to go like that. So this is going to be the line x equals 1. If I go to write my equation, it's always going to be y equals my A value, which was 1/8, x minus my h, so -1 squared, and then plus my k value, which is -5. Again, if you want to find those locus points, you're going to go 2 of your focal lengths in each direction to find those points. So our focal length was 2, so we're going to go 1, 2, 3, 4, 1, 2, 3,